All right, let's take a look at the first section in this new unit. This is section 3.1, and here's the I can statement. I can evaluate expressions. We're going to be dealing a lot with mathematical expressions here. So we're going to learn how to evaluate them, and these may look a little bit different than you've seen before, but hopefully we'll be in good shape. The warm-up, I want you to take a look at this first one and see if you recognize either one of these, and if you do recognize them, hopefully you can remember what they stand for. So the first one is an acronym, PEMDAS, some people say that PEMDAS, and another phrase is please excuse my dear Aunt Sally. If you recognize either one of those, you probably recognize them because these are the order of operations. So order of operations. And that's the order in which we do mathematical operations in an expression. I've got some examples down here. We'll take a look at those in just a second, but let's remind us what these stand for. Now you'll notice the acronym here, PEMDAS, and you'll notice that this phrase here, please excuse my dear Aunt Sally, we've got a P, an E, an M, a D, an A, and an S. So the first letter of each one of these words spells out PEMDAS. So whichever way you use to remember the order of operations, that's fine, but let's remind ourselves what this is. This stands for parentheses. The P stands for parentheses, so we simplify and do any operation that's in parentheses first. We simplify that. E stands for exponents, so I'm going to write a little base with an exponent there. We'll do a couple of those today. And then this stands for multiplication, this stands for division, and then addition and subtraction. Now, one of the common misperceptions is people think we just go through and do them right in order as we come to them from left to right, and that's not the case. We don't always do parentheses, then exponents, and multiplication, and that sort of thing. We do what's in parentheses, then we always do the exponents next. Multiplication and division, those are equally important. Multiplication isn't more important than division, so we do them as in the order we come to them from left to right, and then the same thing with addition and subtraction. We do those in the order we come to them from left to right. So let's take a look at a couple of examples. This first one right here, we've got 6 and then a set of parentheses with a 7 minus 3 in there. There's nothing in between here, so that's an implied multiplication right there, so I'll put a little dot right there. So we've got multiplication, we've got subtraction, we've got addition. Nothing in between the 5 and the negative 2 that's in parentheses, so that's multiplication also. So we've got some multiplication, some subtraction, and some addition. So according to the order of operations, we're going to simplify anything that's in parentheses first. So I'm going to write down this 6, and then let's figure out what we get inside here. This is just 7 minus 3, so that's going to be a 4. Then we've got the 5, the plus 5, and then it's times negative 2. Now that is in parentheses, but it's totally simplified, so I'm just going to write that negative 2 again. Now we've got multiplication here, and then we've got addition. So we are going to go through and we're going to do the multiplication first. So if we multiply the 6 times 4, we get 24. If we multiply the positive 5 times the negative 2, we end up with negative 10. So when we now combine those, notice that we just are down to addition and subtraction. We've taken care of everything else. We're just going to combine those terms and we end up with a 14. So 14 is the answer to that problem right there. Now if you take a look at this one's a little bit more complicated. It's got a few things going on. We've got parentheses, we've got subtraction, we've got an exponent of 2. That thing in parentheses is raised to the power of 2. We've got a plus, and then we've got this fraction bar right here which represents division, and then we've got 6 plus 4 on the top there. So when we're doing something like this, again, we're going to go ahead and take care of what's in parentheses first. We'll definitely simplify that. So I'm going to have 4, and I'm going to leave that in parentheses, and I'm going to square that. And then we've got plus this expression right here. Well, let's think about this. This is 6 plus 4 divided by 2, and we've got to do these in the right order. So we're going to add those two together first, even though this is division. So we're going to figure out what the top is. I'm going to write down the bottom. That's still a 2. Now we're going to go ahead and we're going to raise this to the power of 2. So 4 squared doesn't mean 4 times 2. It means 4 times 4, and 4 times 4 is 16. And then we're going to add 10 divided by 2. That ends up being 5, so we add those together. 16 plus 5 is 21. So the answer on that problem is 21 once we evaluate that. Now there is one exception to the order of operations, and I actually showed you what it is right here, and it is the fraction bar. A fraction bar. A fraction bar represents division, so that fraction bar represents division, but you'll notice what we did first. We actually did the addition before we carried out the division, so that's why it's an exception. We did the addition before we did the division. And the reason for this is a fraction bar itself is a grouping symbol. So it kind of groups the two of these together on the top. So it's kind of like having a set of parentheses on there. And we'd want to evaluate the top, figure out what the top is, figure out what the bottom is, and then carry out the division. So that's the exception to the order of operations. If you see a fraction bar, we're going to figure out what the numerator is, what the top is, figure out what the bottom is, and then we carry out the division, however that works out. And we'll see a couple of those later on as well. So let's take a look at this paragraph right here. As we've mentioned before, variables are usually letters that represent numbers. Now we can use any symbol that we want. Letters are just kind of a convenient symbol that everybody's familiar with. And what we're going to do is we're going to evaluate algebraic expressions, and what this comes down to is plugging in, or the technical word for that is substituting. We're going to substitute the value of each variable, and then we're going to perform the order of operations correctly. As long as we do that order of operations correctly and plug things in correctly, we're going to get the right answer. And if we just talk about the word algebra for just a second, algebra is math that's done with the use of variables. So we're going to be doing a little bit of algebra today, and really that's going to be the focus of this whole unit. So in this assignment, we're going to be working with algebraic expressions, so just expressions in this particular section and on this assignment. And for the rest of the unit, we're going to be dealing with algebraic equations, and we'll deal with that when we get to it. But just so you've got a heads up, this whole unit is going to be about some basic algebra. Now, please make sure you're aware of this. When we're substituting, it's always a good idea to put parentheses around what you're plugging in, around what you're substituting for. And this is going to help you avoid some really common mistakes. When people make mistakes, it's typically because they're not plugging things in parentheses and making sure that they're carrying out that order of operations correctly. So a couple things I want you to notice about the examples. I've got several problems that we're going to take a look at here. The instructions say evaluate. And evaluate means that we simplify and find the number answer. So by the time we're done, we're going to have the same type of thing that we had up here in these examples in the warm-up right here. We got a number answer. What we were doing is we were evaluating there. And the other thing I'd like you to remember is if you see an asterisk by some of these problems, that means they're very similar. And some of them are actually identical to ones that you'll see on your assignment. So make sure you pay attention to those. So let's go ahead and evaluate this expression right here. We've got a 9 plus 2x minus 6 plus 4x, and it says where x is equal to 7. So what we're going to do here is we're going to put, wherever there's an x, we're going to put a 7. So I'm going to write down 9 plus 2. Now this expression is asking for an x, but x is equal to 7. So I'm going to substitute for x. I'm going to put a 7 in there. I'm going to plug a 7 into the x's place. And whenever I do that, it's a good idea to put it in parentheses. So I've got 2x, 2 times 7, 2 times x, 2 times 7, and then we've got minus 6, and then plus 4 times x, 4 times x here, so that's going to be 4 times 7 down here once we substitute in. Now we're going to go through and we're going to do the order of operations. We've got addition, implied multiplication, subtraction, addition, implied multiplication. So let's do the multiplication first. So we're going to have 9 plus 2 times 7 is 14, minus the 6, 4 times 7 is 28. And a little trick here, once you get to this point and we're just combining, since we're just going to be putting these in a big pile and figuring out what the answer is, if you want to do something like this, I'm going to add the two of those together, combine the 9 and the 14, I end up with 23. And we're going to combine the negative 6 and the positive 28. They have different signs, so we're going to find the difference. The difference is 22. Bigger one's positive, so we're going to make that a positive 22. So now we combine those together and we end up with 45. So 45 is the answer to that problem. We're going to come back and look at that in a little bit different way in just a few minutes. Let's take a look at this one right here. You'll notice that we've got b and then a set of parentheses. So we've got implied multiplication right there. 2c, so 2 times c, minus 3, and then close the parentheses. So we've got two variables here. One of them is b, so b is equal to 10. Wherever we see a b, we're going to put a 10. And wherever there's a c, we're going to put a negative 5. So b, we're going to put a 10 right here, and I'm going to put that in parentheses. Then we have the 2, and c is negative 5, so I'm going to put that in parentheses, and then I'm going to subtract 3. You notice we can't really simplify anything here with the 10, so I'm just going to write down a 10 without the parentheses. And then I have 2 times negative 5 minus 3. So let's carry out the multiplication before we do the subtraction. So 2 times negative 5 would be negative 10. and then minus that 3. Again, we've still got a set of parentheses, so let's keep working on simplifying that right there. So I have 10, and then I've got negative 10 minus 3. That's going to be negative 13 once we combine those. Positive times a negative is a negative, and 13 times 10 is 130. So the answer on that one's 130, so we'll go ahead and circle that. All right, let's take a look at this one. We've got parentheses x minus 3, close that parentheses, open up another set, so we've got some implied multiplication right there, and then y plus 2 in a set of parentheses. So wherever there's an 8, an x, we're going to put an 8, and wherever there's a y, we're going to put a 4. So this is going to be parentheses 8 minus 3, and then parentheses 4, because that's what y is, plus 2. Now you'll notice the set of parentheses that I plugged in here, there's not really anything I can do to simplify that 8, so I'm just going to write it without the parentheses. So I'm going to write 8 minus 3 and then 4 plus 2. That looks a little bit better, and then we've got to do what's inside this set of parentheses and what's inside of that set of parentheses before we do anything else. So 8 minus 3 is 5, I'm going to leave that in a set of parentheses. And 4 plus 2 is 6. I'll leave that in a set of parentheses. So you'll notice that we've got this implied multiplication all the way through. So now we're in a position where we can carry out this final operation. So we're going to multiply. So we end up with 30. So our answer there is 30. All right, we'll take a look at the next one. Wherever there's an x, we're going to put a 2. Wherever there's a y, we're going to put a 6. So let's see. This is going to be a 2. I'll go ahead and plug that in parentheses. Put the 6 in parentheses. Minus a 6 in parentheses, put that over 2, and then close the parentheses. Now, it is possible if you wanted to, you can make that bigger set of parentheses, you can make it a square set of brackets. Those are just a different type of parentheses. They mean the same thing, but if you want to do something like that to keep those straight, that would be fine. You'll notice there's nothing we can do to simplify here, so I'm going to go ahead and just write a 2. There's nothing I can do to simplify that, so that's just a 6. Now this is going to be, well, let's see, that's just negative 6 divided by 2, so that's going to be a minus 3. Now I've got to do what's inside these set of brackets or this set of parentheses before I do the multiplication. So this is going to be a 2, and I'm going to change back to a set of parentheses. I kind of flip back and forth like that. This is a 3, so we've got 2 times 3, that's implied multiplication again, so the answer on this one's 6. Now what I want you to look at is there are times where you can get away without plugging in parentheses. So you'll notice I could have skipped to right here, just written the 2, just written the 6, and just written a 6 on the top. That would have been just fine. But I would really recommend that you use parentheses until you can figure out when you can get away with not using them. So you can't go wrong with using them, but if you leave them off in the wrong situation, then that's going to get you in trouble. So I'm going to go ahead and I'm going to leave them off on this one because this is just a 6 minus a 1, and then I'm going to square that. I've got to do the parentheses before I do the exponent, so this is going to be a 5, and I'm going to square that. And again, that doesn't mean 5 times 2, it means 5 times 5. We use 2 5s in a multiplication problem, so this is 25 right there. And then we'll take a look at this last example, and then we'll do a couple from the assignment. So w is negative 3. Now let me give you a little hint. When you're plugging negatives in, it's really important to use parentheses. So I'm going to do a negative 3. P is negative 10, so I'm going to put that in parentheses, minus, and I'm definitely going to put this in parentheses. People tend to make more mistakes with negatives, so it's really a good idea to put parentheses around the negatives. So let's see what we've got here. We've got this big set of parentheses, or if you want to use brackets, that would be fine. So I need to simplify what I've got here. I've got a negative 3 times a negative 10 minus a negative 10. So this is really implied multiplication here and implied multiplication here. So I'm going to write that negative 3 outside. And then this is going to be a 30. Negative times negative is positive. And this is going to be a plus 10. Remember, negative times a negative is a positive. We've got those two symbols in front of each other. We don't like that when we're combining integers and terms and stuff like that. So now I can go ahead and combine the ones in parentheses. That's a 40, and I end up with negative 120 altogether. So there's the answer on that one. Now I do want to go back to one problem before I do a couple from your assignment. Let's take a look at this problem right here. Some of you may have picked up on the fact that these are both constants, and these both have x's on them. So they're like terms. So let's combine the like terms. Let's simplify this before we start plugging in and evaluating. So let's see what we get here. This would be 2x plus 4x is 6x. 9 minus 6 would be positive 3. And then if I plug in wherever there's an x, I put a 7. This is going to be 6 times 7. I'll put that in parentheses. And then plus 3. So 6 times 7 is 42. 42 plus 3 is 45. And you'll notice that that's the same answer that we got right there. So that's totally okay either way there. So we're in good shape with that one. So now let's take a look at a couple from your assignment. And I think we want to take a look at problem number 1 and problem number 11. So here's what I would recommend. Go ahead and take a look at this. See if you can do this on your own. So if you need to pause the video and do problem number 1 and then problem number 11, if you've got this assignment ready to go, try that and then see if you get it right. All right, let's see what we've got here. This is 8k minus 2, so that's 8 times k minus 2, and it says k is equal to 5. So this is going to be 8. I'm going to plug that 5 in parentheses. Got to have that for the implied multiplication. And then we're going to subtract 2. So according to the order of operations, please excuse my dear Aunt Sally, PEMDAS, we are going to do the parentheses before we do any exponents, multiplication and division from left to right, and then addition and subtraction. So there's nothing to simplify in parentheses. There are no exponents. I'm going to go ahead and do any multiplication and division that there are in the order we come to them from left to right. And there's some multiplication right there. So this is going to be 40 minus 2. So the answer on this one is 38. So if you got that one right, you're in good shape. Let's take a look at problem number 11 now. This one's a little bit more complicated. Notice the horizontal fraction bar. So let's see, we've got negative 7 times x. X in this case is 3. And then plus, it says y is negative 4. Now here's where it's really important that you use those sets of parentheses. Make sure, especially when you're plugging in a negative, you put the parentheses there. I've got my horizontal fraction bar, and then we've got the 5, and let's see what we've got here. Now remember, that horizontal fraction bar itself is a grouping symbol, so that means we need to do everything on the top, figure out what the top is, figure out what the bottom is, and then we'll carry out the division that's meant by that horizontal fraction bar. So we've got multiplication, and we've got another multiplication problem here if you want to think of it that way. This is negative 21. Negative 7 times 3 is negative 21. This is positive times a negative. That's going to be a negative 4. That's over 5. And then we still have some simplifying to do to get a single answer on the top. These are two integers, two constants, so we're going to combine those and get negative 25. We divide that by 5, and we end up with negative divided by positive is negative. 25 divided by 5 is 5. So there's our answer on that one. So hopefully that's enough to get you started. Good luck on the assignment. Thanks.